Okay, let's factor some polynomials now. We're going to factor polynomials. Before we even get there, I need to tell you that we get a lot of ways to factor polynomials. All right, and the easiest way is to factor polynomials using GCF. This is the first method, GCF. And the second method has to do with grouping, and we get all of them here on this video. And we get other methods we might be able to see that sometimes we get a difference of two squares. We get that's number 4, and sometimes you get other methods you need to use. But in this case, we're going to use for question number 1, we're going to use a GCF in not even use GCF. We're going to find the GCF. This is the question we asked to find the GCF of this expression. It is 21x to the 4th plus 3x cubed plus 9x squared. All right, the first thing we need to do is to, if we don't know how to find the GCF of 3 numbers, guys, you need to go and look for that. But basically, 21, 3, and 9, so we can tell this 3 divides 9 and 21, all right, and the GCF of the numbers 3, 21, and 9, it's going to be the greatest common factor. That would be equal to 3. So I'm assuming that as you are doing this, you know the GCF for this one is 3. If you're having issues to find the GCF, give me leave me some notes in the comment here, and to let me know that if you want me to go a little deeper on that one. But I'm assuming that guys, you know how to find the GCF of 2 or more numbers. Okay, in this case, you get 21, 3, and 9. The GCF for the number is 3 here. That's 3. And now the GCF, we go for the for the variable, which is x4, x3, and x squared. The quickest way to find the GCF of the same, let's in this case the same variable, which is x, go where you see the exponents. Okay, you get this exponent. This is 4, this is 3, and the exponent for this one is 2. So what the GCF when it comes to those exponents, if you get the same variable, in this case x, you take the one that has the lowest exponent. You take the one that has the lowest exponent. So basically, it's going to be 3x squared. All right, that's the GCF. You take the one that has the lowest exponent. I want you to keep this in mind. x4, x cubed, x2. So x2 has the lowest exponent, is going to be your GCF. But for you who don't see what I'm trying to do here, if I write 21 here, okay, and I'm trying to get the prime factors of 21, so this is 3 and 7. All right, let's take 3 only has 2 prime factors, 1 and 3. Let's take 9, so 9 is equal to 3 and 3. So we're talking about GCF here, greatest common factor. So when they talk about common factor, this 3 is common for both of them, okay, but 7 is not common for both of them. Okay, 3, this other 3, we only have 1 here, so you take the number that is common for both of them. What is that number? That's 3. That's why I get this 3 here. Okay, that's common for both of them. This is 3. So basically I can write 21 is equal to 3 times 7, and I'm going to write 3 is equal to 1 times 3, and I'm going to write 9 is equal to 3 times 3. So one, you take a look at this. Another way, I'm showing you how to find a GCF. So you just take the one that where the 3 is common for all 3 of them. The 3 is common for all 3 of them. Okay, the 3 is common for all 3 of them. So basically, that's how, guys, you find that GCF. Okay, this is the 3 here, 3 and 3. That's the 3 here. Okay. I hope you understand this one. So now let's go for number 2. For this one here, they want us to use the grouping method. They want us to use the grouping method here. This is grouping. Okay. And once that's a grouping, so you're going to group, you get 1, 2, 3, 4 terms here. You're going to group the first 2, and you're going to group the last 2. So once I group this one, okay, but remember I just put the negative sign out now. The negative sign is out, so this parenthesis forces me to, okay, let me erase it and erase this, and I'm gonna start something new. I'm not gonna, okay, let me start something new at the bottom, okay, because I want you guys to see what's in here. So I'm gonna write w square plus 5w minus 3w minus 15. You see? So we're going to use the grouping method to do this one. So what you do, you group the first 2. Okay? And next, you group the last 2. You group the last 2. Yeah, I'm going to take it this way here. But as I'm putting the negative sign out here, I changed something inside, because negative times negative, this becomes positive. Okay, because I just put the negative sign out. If I left it open, then I would put negative sign here, because the negative sign will be distributed into 3w and 15. But since I put it out now, so I need to change the sign in the middle here. So now we have grouped. This is the method we're using. We have grouped that. So now, next thing we're going to do, we're going to look for the GCF of each group. The GCF of each group. Okay, the GCF for w square and 5w is w, okay? And I'm going to take that w and put it right here. And I open my parentheses. So when I get that GCF here, it's like I'm dividing this by w. I'm dividing this one by w as well. So once I divide this one by w, let me put this outside here. This is the w I put out. So once I divide this w squared by w, I put that w here, I'm left with w. This is w. I'm left with this one here, plus. This is the plus sign. Okay. And 5w, this gets cancelled out, as you can see that one here. This becomes 1 plus 5. You see? That's how I factor this one out. Now minus. So 3w and 15. What is the GCF of 3w and 15? So that's 3, because 15 is equal to 3 times 5. And that 3 here, 3 is equal to 1 times 3. So you see what is common for both of them? That's the 5. That's the 3, I'm sorry. That's the 3. I put the 3 out. So what I do here, once I put the 3 out, it's like I'm dividing the whole, this one here by the GCF, which is 3. That's the 3 I put out here. And 15 by 3 as well. That's what I do here. So when I divide 3w by 3, I'm left here with w. W here. And this is 3. Okay, I'm left here with w. Plus, I divide 15 by 3, we get 5. And I close. Okay, that's good. So now, so what I wanted to see, we get a newly found GCF. So what is the new GCF we get now? Because it's common for both of them, w plus 5, which is a 2-term polynomial. That's a binomial. So which is w plus 5. So what do we do with GCFs? We just factor them out. We're going to factor this w plus 5 out again. So we're going to take this w plus 5, since it's common for both of them, we divide everything here by w plus 5. So we get w here plus 5. That's what I get out here. So once I get this out, I open my parentheses. So this is my new GCF. So once I open my parentheses, since I put this one out already, this, what I put here, it encompasses for that one and that one. So I no longer have a w plus 5. It's here already. That's my GCF. So what is left? What is left? And I want you to see what is left. What is left is this w and that minus 3. And what we do, we just take what is left, we put it here, which is w minus 3. So what I'm going to do, let me put the different ink for you so that you can see where they are. So w minus 3. At least you see that w here, with that's what's left, and that minus 3 over here, what's left. And this, you have factored. You have factored this polynomial on top here. W plus 5 and w minus 3. Okay? Number 3. It says 2y squared minus 10x plus 12. Minus 10x plus 12. So the first thing we need to do, we need to find a way to factor this. But I see that we get a 2 here. Let me take a different. Okay, we get a 2 here. We get 2. We get 10 minus 10, which is 12. Oh, so whenever you can simplify, guys, please simplify. So we know the GCF of the whole thing here is 2. So when I divide this one by 2, I divide this one by the GCF, okay? And this is the 2 I'm going to take and put it as factor here. This is 2 factor. So when I divide this by 2, I'm left with y squared. When I divide minus 10 by 2, I'm left with 5y. And I get 12 by 2, this is plus 6. Okay? So I'm going to check this one to see if this can still be simplified. Alright, so what I'm going to do, I'm going to leave my 2 outside. Remember, my 2 here will be part of my answer. I'm going to take it and put it right here. And this one, I'm going to check to see if this can be simplified. Alright, so I'm going to give myself 2 sets of parentheses because of that y square. And since I get a y square here, I'm going to put a first y here and the second y over here, because y times y is y squared. And the next thing I'm going to do, I need a sign there. I'm going to take this sign I have here, minus 5y. I'm going to take this sign and bring it down here. And I need another sign over here. So I take this sign here, over here, times that sign. And I multiply those 2 signs to get the other sign over here. This is minus 5, minus times plus is minus. So then I get my other minus sign over here. So basically, I have 2 numbers I need to put here. So what's going to happen, you take the 6 over here. You see that 6 here? You take 6, you put it right here, and you get the factors of 6. You get 1 and 6, 2 and 3. These are the pairs of factors of 6. Okay, there is no more. 1 times 6 is 6 and 2 times 3 is 6. So we get plus 6 over here. So we agree. But as we get this pair, we need to, only one pair will be able to fit our answer here. Not both of them. Only one. So how do we do this? You multiply these 2 factors, you get 6. That's good. But when you add them up or you subtract them, it all depends, you should get minus 5 over here. Minus 5. So what do you think, according to what we have here, those 2 pairs that give us the minus 5 over here? Because 6 minus 1 is 5. All right. But remember, when you multiply those two terms, you get to get positive 6. But positive 6 minus 1 is 5. That's positive 5. That's not that. And negative 1, positive 1 minus 6 is minus 5. That's another 5. But what if I multiply? Because if I get negative 1 times 6, or 6 times negative 1. But 6 times negative 1, that's negative 6. But we don't have negative 6 here. We get positive 6. But even though when we subtract 6 and 1, which is, not this one, minus 6 plus 1. When we subtract minus 6 plus 1, we get minus 5. But when we multiply them, we don't get positive 6. So this 1 and 6 won't work. 2 and 3 will work, because if 2 plus 3 is 5, we agree, but the sign is negative. So both numbers here have to be negative. So when we add them up, we get minus 5 when we add them up. So we get minus 2 and minus 3. So minus 2 plus minus 3 is minus 5. This is the pair. This pair doesn't work. So this is the pair that works. Minus 2 and minus 3. So I'm going to put 2 here and 3. And you're done. And this is your answer for that one. So once we get that answer here, let's do this here, and this is the answer. So 2 factor y minus 2 factor y minus 3. Okay, and let's finish with the last problem here. Number 4. Number 4. It says factor 121 y squared minus 16y. This is a rule we need to know. Special polynomials. Okay, this is difference. We call this difference of two squares, because this is the difference of two squares. 121 is a perfect square. Y squared is a perfect square, and 16 is a perfect square. Z squared is a perfect square. So there is a rule that says if I get a square minus b square, this is equal to, if I had to factor that, a plus b and a minus b. That's easy. So the second factor has to be the conjugate of the first one. So when I say conjugate, I mean you change the sign. You change the sign between the two letters, okay? So if I get a minus b here, I should get a plus b over here. And it wouldn't hurt. It wouldn't hurt if I write a minus b first, okay? I know my second term would be a plus b. So it has to be the conjugate of the first one. So this is the same as a minus b. I get this one first, and I know that the other one would be a plus b. Same thing. This is the same thing. All right, so let's factor this one here. So how do I find my a? My a, I find it because if I take a square, if I take that a square here, it gives me, if I take a, I raise it to the second power, it gives me that. So basically what I need to have here is a number, when I multiply it by itself, gives me 121. I don't want to go to square root with you yet, or radicals, and we're going to stay there. So what number, when I multiply it by itself, gives me 121? If you want to think about it, it's going to be 11. 11. Okay? And y squared, if I get y squared, what y, if I multiply by itself, give me y squared? That's y, basically. This is 11y. So what I'm doing here, that's 121 is equal to 11y plus, I'm following the formula here, a plus b plus what number if I multiply by itself gives me 16? That's 4. What number if I multiply z by itself, it gives me z squared. So this is 4z. That's the first one. This is a plus b. So the second one will be the same thing, but it's going to be the conjugate of what I just wrote here. So this is 11y minus 4z. And you're done. This is it. 11y minus 4z. And that's your answer for that question here. Don't forget about this formula here. This is difference. We call this difference. Okay. We call this one here difference of 2 squared. Difference of 2 squares. Okay, guys. See you in the next video. Don't forget to comment on this one, like it, and subscribe. And I'll see you in the next video. Bye-bye.